Hello friends, welcome back. Okay, in this video, I want to cover Agentic AI powered by Python and SQL. So what do I mean by that? So the main idea is here, you have seen right now a lot of organizations have already started using Agentic AI in their workflow. Okay, but however, there are in some cases it has been challenged by the, let's say, auditors or saying if the outcome from agent AI is it accurate or not, and that's when we need to go one layer down, which is I call it a semantic layer, where the actual code sits. Like for example, Python and SQL, which is mostly used by these AI agents. So then it's become critical to understand those Python and SQL code. So I want to depict that idea by a very simple image, which I've just got this here. So here you'll see, let's say you used a humanoid to fix car brakes. Okay, let's say you are in future, humanoid used. Uh, it says the car brake repair has been done. Now with that uh, approach, and if we release the car, we may not be like 100% confident that whether the work done by humanoid is accurate or not. That's where we need somebody who is expert in that particular area. Let's say in repairing the brake, we need some human to check that in between. And also we need, once that has been checked by some person, we also need to a real testing, which is like applying brake pedal and to the real testing whether the actually car stops when we apply the brake. That actually creates the confidence. So that's what I'm trying to depict. Anything done by AI agents generally have a low trust initially, and then if it is, let's say, if it is verified by an expert and finally it has been tested, then it actually increased the trust in the workflow. So that is what I want to cover here in this video, stating that uh, when an agentic AI workflow completes its jobs and you want to improve the confidence level of that workflow, we may have to go one level down, which is uh, reading the Python codes or SQL code. Mostly, if you see in agentic AI workflow, one layer down is mostly Python code or SQL, which is actually running the database and bringing the data and giving you the outcome. So the the main idea here, we will go through those Python code and SQL code, which is which is generally used, mostly used. I know there are thousands of Python code, thousands of SQL codes are there, but we will focus on the one which is high value, mostly used in agentic workflow. So without further ado, I will go to that section. We'll start with Python first. Okay, so let me go to the Python section. I hope you got the main idea why it is crucial to go one level down, which is where the agentic AI actually do the coding. So out of so many Python codes and SQL code, I have filtered out the most high value uh, Python codes, which is used by agents in their workflow. And I'm going a little bit more technical in this section. I know, but we'll try to try to explain them as in plain English as well as some animations, so you understand what actually those code does. So at the end of the day, when we complete this video, you have a very fair understanding of those widely used Python code and SQL code. So starting with the first one, which is comprehension and generator. This this kind of syntax you will normally see when you, let's say you are auditing the agent's workflow, and you will most likely come across list, dictionary, and generators. So when I say these things, how does those code look like? So on the left hand side, I'm trying to depict those code. Here you will see we start with the very basic class creation product, which and define, initialize some uh, parameters to it. So here you can see ID, cost, and actives has been initialized, and then you pass the actual data, which is like here using uh, this uh, formula. You put uh, data like A1, A2, B2, and all these things goes into particular columns. Now, if you want to fetch certain information out of it, where you can use a dictionary kind of approach, which is this one single line. You will see generally agents going to write this kind of code. So you should able to understand what is exactly this code mean. So here you will see it is nothing but it is fetching from the dictionary. If it is, if P is active, which basically if it is true here, for example, these two lines true, bring those two lines as an output for the prices. So here you it will bring A1 with 9.9 and C3 4.2, and it will give you the output. So for generally, if you want to if you see come across this, you can think about this is where the dictionary has been used, and it is like all these informations are stored in memory and you're fetching the information from the memory. Similar to that, you will see this kind of code also, which is for widely used for token generation. So what actually happens, you may have a multiple documents like PDF and all that, which will be comma separated, kept in in a dictionary, and then you want to flatten out. Basically, you want to make a list out of it. So you can use this chain command, which will make this into like this. Okay, so where it is used, this is used for your text generation, which actually get fed into like training your LLMs, and so that's why this kind of command you will see. One of the I will just go a little faster because I want to cover everything. Here another one is the you'll see like generator type of command, where you see open bracket and close bracket within this section. This is basically used when you don't want to utilize too much memory, RAM memory. It execute one at a time. That's why it is called generator. So what happens when you fetch this information into the system? It will run line by line, one at a time, and check the conditions. So for example, this is true, it will take it. This is false, it will ignore, and then it will take the next one and the next one, and then the last one it will be taking it. So it is one at a time, and it doesn't store a lot of memory. Uh, Hence the advantage of using generator is there. So here on the top right side, I want to just cover that benefit of using dictionary. Then if you want to use why do we use nested comprehension, and then finally what is the benefit of generator. So dictionary is like it will hold the whole data, your all data will be stored there in the memory, and when you do a lookup, I mean, when you want to bring something out of it, like here in this case you want to bring the active product, it will fetch very fast. Okay, but definitely there is a trade-off where the memory will be utilized. So that's why I'm mentioning here. So if you are using fetching the data will be fast, but memory will be utilized. But just opposite to that is like a generator, where you don't store the intermediate calculation. Instead, you are focusing on the final outcome, which is like a total, max count, all those things. You don't care what is happening in the, in between. If you want to do plus plus plus, you are interested in the final count, use the generator, because it doesn't uh, store take a lot of memory. Just one at a time, one calculation, next calculation, and all that. So when the memory is limited, you can use generator. And then this is nested list is uh, where you will see this kind of code. Is nothing but you are doing the token generation, and you may have duplicates in it. It's okay, because let's say you're filling the long PDF, a certain words will repeat. So but those word repeat is important, because there is some context to it, right? So it will keep the order, in which order, but it will be a very flat kind of a file like this. You see that it is all are been put it into comma separated, which helps in creating those vector for LLM trainings. That's the idea of using list comprehension. So pretty much you will come across this kind of code, and now you know what is the benefit of and how to read those things. So this is for the first one, comprehension and generator. Let's go to the next one. Before that, I want to just show you how actually when you run this command, what actually happens. That way you can understand what is happening. So I'll click here at the next. You can see uh, what is actually selected. So here in this command, the first part is look for true value, which is here. Okay, if it is true, that has been selected from this line of command. First it is this got selected, and then once it is got selected, you just create the next item, where you are trying to do a multiplication 1.1 with the amount, which is like 120 and 80. So that will be done now, and one at a time it will be so for 120 this is multiplied. Secondly, it will be multiplying with 80, and then the the outcome is being generated. So this is how this command actually gives you the output. Okay, so if you want to understand what is exactly happening, this animations helps you to understand what exactly this code did from the data to output. I hope it's helpful. Let me go to the next one. So this is also another very widely used in Python, which is Pydantic import base model and validation error, and also the data class. Every time you see this, you don't have to get confused why it is used. It's not a big thing. Big thing in the sense, it's not like very complex to understand. Very basic thing which is necessary for uh, agentic AI workflow usage. Now, let me talk about first thing is this data class wrapper, which is used here. What you are doing is nothing but making code more readable. Okay, if you don't use at the rate class, you may have to use that initialization, put all that under those self filled and all that things. It's become little more complex to read, versus what you read is very simple here, because you added that at the rate data class. That's the objective. So you will see this kind of thing at the rate data class in the code. Don't get surprised what does it use. It just simplify that and remove those things like initialization which you see in Python code. Secondly, when you see Pydantic, importing Pydantic and base model, and so again don't get too much what is this complex thing. Nothing is there here. What Pydantic does is do a validations for your input data. So in whatever which we feed to LLM, and whatever comes out of the LLM, we want to ensure the data for number, it is in number format. Supposed to be text, it should be in text format. Those checks are done using this library, Pydantic. Okay, so here I will show you an example. For example, this is the text. This is the text data. This is in a float format, which is a number, and this is a source, which is a list format. So all of them are in required format. So it is a good, and it will give out the result. But if it is in case the data is something not in the correct format. So for example, here the confidence, which is supposed to be a float, but it is a text. So that's a problem. And again, sources has to be in a list way like this, comma separated, and provide a list. But here it's just simple text. So in that case, it will throw out an error. So the main idea again is to do validation of the input data, be it coming from LLM or going out of the LLM, and you're passing to the second processing. This helps. Okay, so again the same thing. I just want to show it through an animation so that it you remember it for a long time. So here I will just run it. So symbol is in the string format. This is in the string format, which should be fine. Okay, quantity is in the integer. It's in the raw value was 10, but it can be easily converted into integers because it's a number in fact. So this is fine, so it get taken care of it. Next, this is 191.5, which is like a float number. It get validated, it is passed. Now these are the things we are expecting in the fields we are expecting, and we don't expect anything extra, so which will automatically be dropped by the Pydantic base model. So this is how it is very useful to use Pydantic base model for your input data validation. Okay, let me go to the another section, which is again widely used by agents, AI agents. Now here I want to talk about async IO, and there is something called async IO gather. So if you see these things in the code, basically it is talking about doing concurrent thing, okay, versus sequential thing. So async IO dot gather is very important, I will say. uh, uh, Python command exists, which is a part of async IO library. So what it does, it do a parallel uh, work distribution. So whenever there is a, for example, there is a 3 questions coming in the list, what it will do, it will send three, it will create a three API calls. One for this question, second for this question, and third for this question. A separate three calls, API calls. Parallelly, it will send, and whatever the answers comes back, it will gather it together and print the result. So advantage, it doesn't have to do the work sequentially. One first do this, wait for the answer, then do this, and do this. So that's the advantage. So uh, if you want to do parallel thing, use this is sync.io gather. But if you want to do, so in some cases you want to do sequential. So in that case, use the sequential methods, which is like you do this one at a time. It completes the result and then it go to the next one. Sequential is also, in some cases you need sequential steps. Use, there are cases you cannot do second step after before first step. First step has to be completed. Then you use the sequential. So you can go through the code and you can check, oh, this is doing a parallel. Oh, instead of it should have done sequential. Those kind of validation you can do when you understand what is happening here. So again, the same, there is a trade-off. Okay, so it's very basic thing to understand. So let me show you in animation, that way you can remember for a long time. So when you use normal sequential, so this is how it will do. It will take that first one, process it, do the second one, and the second processes, and third will come that way. And when you use async gather, that will be all goes to a different API call, and the informations are processed together. That's the advantage. Okay, let me move to the next one. Yeah, so you will see this kind of also very much in the code, like calling from function to import LRU cache and wraps. So what are these things? Let me 1 second, I'll just grab some water. So for where you don't have to calculate multiple time, you use the cache. So here you will notice LRU actually stand for least recently used cache. What it does, when you run this command, if there is a calculation which is happened previously, it will store in the memory. So that way it doesn't have to rerun the calculation again. So if you come across this thing, you understand this is making the model run fast and use it from the memory to do the thing. Then another thing you will notice is the wrap function, okay, which is basically used to apply the function which is already there to another function and bring this characteristic to work with it. And it also can be used for passing the function to the for the return generation. So in short, you will if you see this kind of a decorator, if when you see at the rate, is basically you are applying those functions on top of the other functions. Okay, so here you will write the whole let's say you have written this whole logic and you want to apply that things to another function. You just put it at the top of that function, you can see at the rate, and then pass the parameter to this function. So this is how you can do a chaining using the wrap function. So you will nothing again complex, but only you're applying to a function. So you can backtrace, okay, what is happening here. If you want to know, you can actually go to the retry function and understand what is happening for which has been applied here. Okay. So let me again show it what is happening uh, when I talked about cache. So when you call this particular first uh, this is a list, right? If you're calling going through this one by one, you're calling a function, you read that text, so it gets stored into your memory. A is there already, you store it in your memory. Okay, then next came B, again you store it in your memory. Then third, again you see the third one, A, it will not do any further calculation because it's already there in the cache. You take it from the cache and send it to the, so this how it saves the time. Okay, again C is the new thing, it will be added. Then B is again repeated because B was already there and now B is again coming. You take it from the memory, it doesn't have to calculate again. So you'll see this is not calculated. Finally again A will not be calculated. So cache is used for this kind of thing. It saves a lot of time. Okay, let's move to the next one, which is about pattern matching, walrus, and unpacking. Uh, this is like very, for example, you will see match for event in events, match event case. This one, if this case is true, you do this. If this is true, then you do this. And finally, if it not there, you do this. So it's again is a very simple logical application to read through. So I don't want to spend too much time here. Uh, One of the thing you will notice this walrus kind of application in the code. So again, don't get scared about this. It's nothing but it's doing uh, it's taking the test, it's doing the check and processing at the same time. So that's the advantage of using walrus. But just syntax benefit is not actually uh, real benefit in terms of speed. You will also see the syntax like this, okay? Config double asterisk default double asterisk overrides, okay? Now this is actually what happens when this I just want to spend a little more time. So here what happens in this dictionary, the first default data is been fed here, okay? And then the second part, which is on the right hand side, whatever comes after is also been put it here. But if there is a duplicate, so for example the temperature, you see temperature is here, temperature is also here, but the temperature, the first one get overwritten by the second one which is on the right hand side. So this double asterisk is a unpack method in dictionary, is by default in the Python it is there. It will unpack the whatever dictionary is there, spread it spread it into another dictionary, but it will deduplicate. It removes the anything in the dictionary if there is uh, repeated twice. It will take the one which is on the right hand side. Okay, so this is where the outcome will look like. When you look into config, the config will take this. So what you see, GPT-4 is already taken. The temperature you notice the output 0.7 and 0.2, it has taken the second one. And same for the maximum token, it has taken the second one, which is 500. Rest it has taken from the first one. So that is what this is also a very important one which I want to spend a little bit more time. Okay, so this match and case is like an if statement. Just I will quickly show you what is happening. So it is just check is it a tool call in the name is there, then run this. If it is there, just run this one. If it is error, and so on. Okay, so that these extra will be wildcard will be ignored. That's what it is doing. Now another, you will notice use of import polars as PL, uh, which is another benefit of using together the entire column in calculation, which is much faster than doing a loop. Okay, so this if you come across import polar SPL, it's basically trying to do entire column wise operation, which is much faster than row wise operation. So speed, if you want to increase the speed, use this kind of thing. There is also, you will see across events, something called event.lazy. So what it does is actually doesn't do the calculation before it plans the whole thing. So it will go through the entire code. Let's say there is a filter, there is a select group by and all that thing there. It will understand this part first and then execute the code in a such a way that the outcomes comes fast. So this this is important to use in some cases, similar to if you have seen in SQL also. When you send a command to SQL, the SQL server actually do that calculation based on the SQL command. It decide what part of the execution has to be done first, so that it can give the result faster. Hmm. Same logic here. So again, if you come across this, nothing to worry. And then you will see this is like a filter, dot filter, group by, use for the function. And finally, the results will, the execution will only happen when you apply the dot collect command. Okay. So let me show you actually what happens here. This, let's say this is your data. The first thing it has to do is this amount has to be greater than 0. So you see here 1, 2, 3. So this has to be excluded. Ben, which is greater than 0, has to be excluded. So we'll see in the action. So first thing is this has been done. Okay. Then you want to group by user. So you come to this user column. You see Anna is twice repeated. So it has to be grouped into one, because when you do a grouping, you need to also specify group with what. You need some numbering or something to be grouped. So we are trying to group by amount. Okay, so this is the amount column, we will group it, and after that you want to rename that column. You can use the alias as a syntax, and that will rename the column. So let's see in the action. I praise it. So next is owners. You will see this Anna has been selected in a different color than Ben, and then the results of them has been added, and this is how the result will look like when you run this command. Okay, so it is again is much more faster than Python, because you are using vectorized command. It's like full column to column calculation. Sorry, column to column calculation. Let's go to the seventh one, PySpark, Flink and Packet. So you will see a lot of data pipelines are generally using PySpark.sql. Uh, Again, this is similar to Panda, which we have in Python, but it helps you to use a distributed network. You have like a cluster of computers. It spreads the work and give it to different workers to do the processing. That's why uh, PySpark is very widely used. I think Databricks uh, is built on this. They use the original, the founders have were part of this development of PySpark, and then they used in Databricks to uh, continue to utilize the benefit of the memory management and speed with which the data can be fetched out. So very powerful tool. So if you come across, you can understand these are nothing but doing this similar work but at scale. So it can actually handle at GBs of data for processing. Again, you bring the data, you do the grouping, do the same logic, and then you finally come out with the result. But it's for the huge data. Okay, now this is for let's say it's for the batch process, and if you come across Flink table, this is more about live data. So it does the same thing. The only difference you will see something called watermark for event. So this is special things in Flink where it actually waits for the execution to complete for 5 seconds and then collect the information and send it as a result. It's a very interesting concept which I want to just quickly cover here. Uh, uh, okay, so let me show you in the what is actually happening. Then it's better to understand this. So first, let's talk about PySpark. What actually going to happen here? Uh, it actually distribute the whatever command we send to Spark, it actually send its information into different uh, executor. So think about executor is like a different machine. Like in cloud, you have a multiple computers. So it will send some part of the execution to some computer, computer one, computer two, computer three, and then it will collect those information and send it back. That's why it is called distributed, work. Advantage again, you do things parallelly, and also there is an assurance that if let's say if the one system fails, it will give it to another system to do that whatever the remaining part and get the result out of it. All that logic has been built inside that thing. So let's see this in action. So if I click next, so first thing, it selects the column which is needed for this calculation, user and amount. Okay, and then if I click next, it will do the first part of it, which is group. It has to group by user. So here Anna, if it Anna and repeat it multiple time, it will group Anna and them to a single thing. Then finally the result which is coming from the all the executor will be fetched back. Okay, so that's about the Spark thing, like a distributed work. But also I want to cover the Flink, which is more of a like a live stream. So here uh, it takes and send the calculation for each thing, and then at certain time it recollect the information. So I was talking about this uh, watermark interval for 5 seconds. So here what it will happen, it will wait for the last 5 seconds and cover, fetch the collective data in the dashboard to ensure it doesn't miss out some portion which is yet to be executed. So that's why there is a wait time here. Now this 5 second can be increased to higher seconds, but that will reduce the liveness of the dashboard. So again, this has to be decided. If you want how much time you want to wait to ensure your dashboard uh, is updated, you can decide on that so that you cover everything. Or if there is a certain things you cannot wait for long, so because of that the dashboard will not be a real time, you keep the time to be lower, 5 second or so. Okay, so another thing is use of Parquet. So it is very useful because it is much more smaller than CSV file. So if you see this kind of usage, it's just to increase the speed of processing over CSV. Okay, so that's what I mentioned here. Uh, what it does is it removes the packets. Why it is smaller than CSV is basically it removes the duplicates. Let's say in a column there are something. Let's say you talk about one state. Okay, you repeat the state name again and again in the table. That can be compressed by making it not duplicate one. Only keep the information. That way, the size of the CSV can be reduced. Okay. All right. So other than that, some other things you will come across. Just a quick thing. I just want to keep it here. Yeah, I think this is covered. One basic idea, you will also see some sort of kernel things. Just quickly, I want to cover that if the calculation is happening at L1 uh, memory, it will be much faster than L2, L3, then RAM, then SSD, and then finally this thing. So its idea is the travel time between CPU and the memory. You reduce the travel time. Closer it is near to CPU calculation, faster it will do. So something a lot of uh, engineers do that in designing their calculations. I don't want to go here too much, but just keep this idea in mind. If you see some of the code like this is more about memory management. Okay. So yeah, this is what I want to talk about. If it is in CPU cache, the time is generally in 1 to 10 nanosecond of time for to reach to CPU. The problem is the memory size. You cannot have too much memory at L1, L2 level. Okay, so this is limited by that. But again, if you are using RAM, you can go to GBs. But again, that cannot be too much. RAM also has a limited. And then you want a terabytes of data, you go to SSD. But again, if you go to SSD, it is little far away from the CPU versus RAM, and also again its speed is slow compared to RAM. So that's the thing you have to keep it in mind. Okay, and some of the codes if you see across, so you can relate it is, if you see across, these are related to caching memory, these are related to RAM, and and so on. I know this is too details, but just a quick glance about it. Other thing also you will see is Apache Airflow, which is used primarily to schedule and sequencing of the jobs. It's not a actual syntax semantic layer. I'll say it is more about job creations. Where also you will see TensorFlow. This is again to utilize GPU TPU together for VRAM. This is more of a mathematical approach, I'll say, than than the the code part of it. Okay, I'll take a pause here and then we'll talk about SQL.